Hello guys, welcome to another video. In this video, we would see how we can manipulate messages using LangChain. Like we have multiple types of message types, right? Like we have AI message, we have system message, we have human message. I'll explain everything. Like when you want to query an LLM based on some prompts, then you have to use these messages only. And if you see here in this example, I am trying to prompt my LLM so that it will act accordingly. If you see, I'm trying to prompt my LLM in a way that it is able to multiply two numbers provided in the query. So I'm just trying to prompt. If you see the first human message, what is the product? Then I'm saying when we get a human message like that, then AI message should be something like this. It should generate a tool call. And then the tool should be triggered and the tool message should be the value of this multiplied number. And again, if you see in the human message, we have +4. So again, AI message should generate two arguments, one with the product of these and the second with the another argument called 4. And again, the tool gets called and this should be the output of the tool. And again, AI should generate that the product of +4 is so and so output. So this is how we are trying to prompt the LLM, or we are trying to tell the LLM to act like this when you get this kind of query, right? So to do these kind of talks, or when you're trying to manipulate the LLM, or we can say like when you're trying to instruct the LLM to behave so and so way, then we need to use these kind of classes like LangChain classes, like human messages, AI messages, tool messages, system messages, and all this. So how can we filter out, or how can we manipulate, or how can we trim the context or the tokens, and all those things we will see in this class. Before going that, let's understand what is token. Token is nothing but a piece of word, or it can be a single word or some part of the word, or it can be mixed of two words. Anything can be called based on the encoding used by the LLM. The token can be decided. Like, so if you see, a token is typically a word, a part of word, or even a single character can also be decided as a token based on the encoding used. I'll show you what is encoding and how the encoding is being used. Depends on the encoding use. Every word, punctuation mark, and sometimes even part of the word is split into tokens. These tokens are what the model process, and each model has a limit on how many tokens it can handle in one request. Like if you give a very long text, it can't understand. That's the purpose of the RAG, right? The scenario why the RAG has come is like we can't dump the pages of data into the LLM. We have a limitation that this LLM can take only specific number of tokens. That's okay. We'll see the RAG in another tutorial. But I'm just saying, like when you query the LLM, you can send only a specific number of tokens, not more than the limit which the LLM can handle. So in this tutorial, we'll see how to trim that, or how to filter out the messages, or how to filter the tokens and all those things. Okay. So now let's see how a basic example on how we can do tool calling or function calling using the prompting by using this human message, AI message classes in LangChain. So if you see, I have two methods, add and multiply, and I'm calling them as a tools, and I'm binding these tools to the LLM. So from now on, we'll use LLM with tools. That's it. As I explained before, in this examples list, I am trying to manipulate or instruct the LLM to behave in a way whenever it gets a queries like this. That's it, right? That's what I explained: human message, AI message, tool message, and all. And then we are giving it a query so that it behaves the way we have passed in the example. That's it. If you see what is runnable pass-through and all, you can check my previous video. I've explained what is runnable pass-through and all. So we're just passing the query at the runtime, and when you want to pass it at the runtime, you can use runnable pass-through, and this query will be passed to the prompt. So this value gets filled, and once this prompt is passed to the LLM, and when you trigger this, it has literally responded the way we have asked it to mimic above. If you see, it first so if you see above, we first multiplied these two and then did this sum with 4, right? So that's what it said. Here we are asking 119 times 8. So it is doing the multiplication because it is calling the multiply tool, and then it is adding. We are saying -20. So it is adding -20 here. So it is calling the add method here. That's it. So this is one of the example on how we can ask the LLM to mimic using the prompts. So LangChain provides a method called trim messages, and it takes set of arguments, and I'll explain each and every argument on high level, and you can read this comment as well to get it more clarity. And here I am giving some messages, like system message will be the first one, then human asks, then AI responds, then human asks another one, AI responds, and again human asks. So this trim message method, when you, the first argument will be the messages, because we are trying to trim these messages. Sometimes we might not need all the AI messages, sometimes we might not need all the human messages, sometimes we can ignore the system message, which is nothing but the instructions, or sometimes we just need only the last two messages as well. So that kind of filtering of these messages can be done using the stream messages. The first argument is this messages, which is fine. The second is strategy equal to last. That means we are just asking it to pick the only the last messages. We give importance to the last messages, not from the starting. If you give first, then it give importance to the first messages. That's it. And token counter. I mean, to calculate the number of tokens we have in this prompt, we are using again LLM to calculate the number of tokens our messages has. That's it. That's what it does. This token counter means using the LLM, it calculates the number of tokens, the total number of tokens here. That's it. And max tokens equal 45. So if any of this message has a tokens greater than 45, then it trims those tokens. That's what this argument represents. We are saying that after trimming, the conversation should start with the human message, and the next is end on. We are saying the after trimming, the conversation, I mean the list of message should end either with the human message or with the tool message. That's it. Include system, we are saying whether to include system message or not. Yes, we need to include the system message. That's what we have. Allow partial equal to 2, which means that for suppose if this specific message has a token greater than 45 tokens, then it will trim till 45 and it returns. So it will not return that message after 45 tokens. That's what we are saying. So we are just allowing it to return the partial message as well. For suppose let's assume till here it's a 45 token, then it will return only this. It will trim out this part. That's what we are saying. If you see, when we run, we got a system message because we are asking it to return include system equal to true and end with human message. That's why we got it. And if you see start on equal to human, we don't have start on equal to human because as we said, the strategy equal to last, at the end we don't have the human message. That's why we got it with the system message, and as per this end on equal to human or tool, it ended with the human message. That's it. And as if you see, the max tokens equal to 45 here, so it trimmed out these in the middle part as well. Now when I increase the max tokens equal to 75, it has returned many other messages as well. Now if you see, it started with the human message. System message we asked to start, so the next message will be human message only, and ended with the human message. That's what we are telling here. So as the token size is increased, it has even returned the more number of messages. So in case if you want to know how many tokens my particular message or a query has, you can use like llm.invoke of whatever the query you have, and in the response we have a dictionary called response metadata, and inside response metadata, it prints out the number of tokens our text the LLM is treating as. If you see here, I just wanted to show you on how it treats, like with the how it reads the space and how it reads the word and all. If you see, it has still this colon, and it is treated as 32 tokens, but when I add a space and man, it treated as 33. So it treated the space and man as one extra token, and again if I add another space, it increased one more. So one space and a man treated as one token and another space treated as one token, based on the encoding this particular LLM or the OpenAI LLM uses, we get those many number of tokens. Now before we saw the token, how many tokens that specific message has should be calculated based on the model. Like we are asking a model to calculate the number of tokens we have in that specific message which we are passing. Instead of that, we have another option called token counter equal to length. So in this option, it just calculates the length of all the words. That's it. So when we say max tokens equal to 2, then it returns only 2 messages, the last 2 messages. If you see, we gave it last. If we give it first, the first 2 messages will come. And again, as I have mentioned 6 here, max tokens, it has returned the last 6 messages. That's it. And the others arguments are the same, the start on, end on, include system message or not, and all those. We saw two options. One is asking the LLM to calculate the number of tokens, and second is to just do the length of all the words, right? And we can even use the custom token as well. We can create a method which calculates the tokens. If you see here, we are using a tick token. This is an open source library from OpenAI. So using this uses encoding, and based on encoding it calculates the length of the token. So we just have to pass the text, that's it, and it encodes based on this 200k base encoding and calculates the length of the token, length or the number of tokens for the passed text. This is another method where we are just classifying whether it's a user message or assistant message or a tool message or a system message, and then calling this particular method and calculating the text. So I mean the length of the role, user, assistant, tool, system is different, right? So we are just calculating the token length for these roles as well, and then we are calculating for the actual message or the actual context. That's it. So we can use this custom token counter. That's it. And then the other parameters are the same. So instead of using like above, where we have used token counter equal to length and the token counter is equal to LLM, we have another option where we can create the custom tokenizer as well. So now I'll show you on how we can filter out the messages as well. Till now we saw how we can trim the messages. Now I'll show you how we can filter out the message as well. So when you open this one, I just want to show you how this class and what kind of arguments this class has. If you see, this AI message has the context, example, ID and name. Just remember this ID and name because we filter out on these. And similarly, like not just AI message, like even the human message and system message, everything will have the ID and name. If you see, ID is one parameter, name is other parameter. So now, so I have a list of messages. That's it. One is system message, human message, AI. So also this order is important. We can't just give the wrong order. We have to give the order in which the LLM behaves. So first system message will be there. If you don't have system message, then human message will be there. Then the AI message will be the next after human message. We can't give the tool messages next, because once we trigger the AI message, once we get the AI message response, then we have to trigger the tool, right? So that order is important. So we can just filter out by calling this filter message, which comes from the LangChain core package. Filter message of what are the messages you want to filter, and include types equal to human. So what we are saying is just keep only the human messages. I don't want any other message. So just filter out based on that, and exclude. And next is exclude names. So I don't want any messages which has the name as Praveen and Chinna. Here I have only one name, Praveen. So it just filter out these two human messages. That's it. Because I'm saying to exclude the names, these names alone. That's it. It returned the other messages response. That's it. So we can even build the chains, like we have to just need this prompt first, then LLM and chain. You can use this chain.invoke of and pass all the messages. This is just the basic stuff. That's it. And now, and the next option is on how we can merge the messages. If you see, I have multiple system messages and multiple human messages. Instead of passing them in as separate messages, you can even merge them, and LangChain has a method to merge all those. So merge message runs. When you pass these messages, it merged all the system messages into one. If you see, you always respond very funny. See, new line, and you always respond very funny. It's a single system message, and the next is a human message. That's it. And you can just query with these messages. So this is how we can trim, filter, merge, manipulate messages. And if you ask me when to use messages, these message classes, we use these message classes when we want to trick or train the LLM to behave so and so way, like in a specific way, like how we have used this for the tool calling. That's it. Thank you so much for watching.